Hi everyone, today we're going to be talking about polynomial arithmetic. Arithmetic is just a fancy word for those four principal or operations that we do: addition, subtraction, multiplying, and dividing. We will be dividing in this chapter, but for now I just want to focus on the first three: adding, subtracting, and multiplying. When we're adding, we're just combining like terms, and those are terms that have the same variables and the same exponents. So here we have in orange two like terms. We have 3x squared y and negative 2x squared y. These are like terms because they both have an x squared and they both have a y. We also have xy squared and 5xy squared. Now these are both the same like terms because they both have an x and they both have a y squared. Although this one doesn't have a 5 and this one does, they're still considered like terms because we're only looking at the variable and the exponents attached to those variables. So although these both have x's, they both have y's, and they both have a squared, they are not like terms with each other. So this one is a like term with this, but it's not a like term with this. Because in this case, you have the x squared. That squared is attached to the x, meaning you actually have two of them and one y. But in this one, the squared is attached to the y and not the x. So if I were to expand this, I would have 3x, x, y, and in this one, I would have x, y, y. So they are not like terms. You want to make sure that the exponent is attached to the same variable on both of them. Once you identify like terms for addition, you just combine them. So for example, if I were combining these two, it would be a positive 3 and a negative 2, which would give me a 1, which is just x squared y. When we subtract, we want to convert our problem into addition by distributing the negative sign, and we'll get into what that means. And then multiplying, we're going to be using the area model, but I'll go over a couple other ways also. All right, so for the first example that we're going to do, I'm going to start off by combining my like terms. You can do this a few ways. If you have colors like I do, you can go through and identify them, giving them a color. So here I am doing x to the power of 5, and I have another one here. Another way that you could identify this is by underlining or putting different shapes. So for my negative 3x squared, I'm going to go ahead and underline that once in blue, and I'm going to find the one on the other side, which is here a positive 5x squared. You could also do something like a square. My constant, it doesn't have a variable attached to it, so I'm going to find it on the other side, which is this negative 6. I noticed that I still have another term here, which is this positive 7x cubed, so I'm going to go ahead and double underline that. So in this one, I did colors and I did shapes. So I know that my circles, my green circles, will go together, and I can go ahead and combine those. So x to the power of 5 plus a negative 2x to the power of 5. I have a 1 minus 2, which gives me a negative x to the power of 5. My exponent won't change. It'll stay the same. My variable also doesn't change. All I'm doing is combining the coefficients with one another. Next, I'm actually going to do my pink because that's my next biggest exponent. And if you remember in the last video, we talked about standard form, ordering them from biggest to smallest. So since this one doesn't have anything to combine it with, I'm just going to bring that straight down like that. Next, I'm going to do my x squared. So I have this negative 3x squared plus a 5x squared, which gives me a positive 2x squared. And then lastly, I have my constant. So 11 plus a negative 6 gives me a positive 5. And that becomes my final answer. So again, I'm just identifying my like terms and then combining them. With the next one, I'm going to do the same thing again. I'm going to start off by identifying my like terms. So here I have an x cubed, and I find one on this side also. I have an x squared, and I have another one here. And then I also have a constant and a constant. So x cubed minus x cubed will just cancel out and I won't have anything there anymore. A negative 7x squared and then a positive 2x squared will give me a negative 5x squared. And then my constant will be a positive 7 plus a positive 5, which would give me a positive 12 as my final answer. And that's it. So remember that when you are adding, you are combining the like terms and writing them in standard form. Okay, so for subtraction, we're going to do something similar. If you remember part of our vocabulary, it said we were going to convert to addition by distributing the negative sign. And then once we have an addition problem, we can just repeat what we did here. So that negative sign, I'm actually referring to the subtraction symbol. I'm going to call it a negative sign for the sake of this, because then I can say that this is a negative 1, which I can distribute to each term on the second one. So same here, I'm going to distribute that to each one. Alright, so the first part doesn't change. We're going to keep our x to the power of 4 plus 3x cubed plus x squared minus 10. But the second part, we're going to have a negative 1 times a negative 4. So we will have plus 4x to the power of 4. A negative and a positive will give me a negative x squared. And then a negative and a positive will give me a negative 15. From here, we just have the same thing that we did up here, and we're going to start combining those like terms. I'm going to start off by identifying my x to the power of 4, because that's my biggest exponent. Remember, you want to keep the sign in with that, because that's what you're combining. You want to know what you have to do. Next, I'm going to combine my cubed, and in this case, I only have 1. Next, I'm going to combine my squared, which I'm going to put a square around. And then lastly, I am going to identify my constant, like that. All right, so x cubed plus, or x to the power of 4 plus 4 to the power of 4 gives me 5x to the power of 4. I have 3x cubed and nothing to combine it with on this side, so I just get plus 3x cubed. I have x squared minus x squared, which cancel each other out, so I don't have to write that. And then negative 10 minus 15 gives me negative 25. And that gives me my final answer. So again, you want to distribute the negative sign, and then that turns into something just like we did up here in addition. You combine the like terms and write it in standard form. So with this one, I'm going to start off with writing the first part, which doesn't change. A negative and a negative will give me a positive 3x to the 4th. Negative and a positive will give me minus x cubed. Negative and a positive will give me a minus 2x squared. Negative and a negative will give me a positive 20. Okay. Identify my x to the power of 4, and I have another one right here. Two x cubed minus x cubed. A positive x squared and a negative 2x squared. And then a positive 20. Okay, so 1 plus 3 gives me 4x to the power of 4. 2 minus 1 gives me a positive x cubed. X squared minus 2x gives me minus x squared. And lastly, we have that positive 20. So you will notice that with subtraction, you're just adding one additional step, which is that distribution. With addition, all you're doing is identifying, then combining, and writing it in standard form. In this one, you have to distribute, identify, then combine, and then write it in standard form. So they're both very similar, except subtraction just gives you that one extra step. Okay, so here's our next one. We're going to be multiplying now. So here we have a by. We have two binomials, and we know they're binomials because each one only has two terms. So we've done these in the past, so I went ahead and I started my area model where it doesn't matter, remember, where you put each one, as long as what's inside of the parentheses stays the same. So like you can't say negative 3x and then negative 3. You need to keep each one together. So we have negative 3x times x, which gives me a negative 3x squared. A negative and a negative would give me a positive 9x, a positive 1x, and then a negative 3. So here we use our peanuts, or you could be using combining like terms, just like we did in addition. And now we can just write this as negative 3x squared. 9 plus 1 is 10x minus 3. And that becomes our final answer. There is a couple more ways that we can do to solve these. The next method that we learned was the distribution method, where I take the first binomial and I separate it. So here's the 3x squared and then that plus 1, and I multiply each one of those terms by the second binomial, which is x minus 3. So I distribute and I got this, distribute, got this. I was able then to combine the like terms, and you'll notice that you get the same answer. Another form of this is FOIL, where you multiply first, so the first terms, outer, those terms, inner, those terms, and then last, which is essentially distribution. The last method I'm going to go with along with you on this one. We won't do this one at all in class, but it is a different method that some teachers prefer to teach. So I'm going to do it, but I'm not going to you won't see me doing this in class. But if it works for you, you can use it. So just like when you multiply any two numbers together, you can put them vertically with a multiplication sign. I use the circle instead of an X, just so I don't confuse it with this. I'm going to start off by covering the first term, and I'm going to multiply. So 1 times negative 3 is negative 3, and then negative and a negative would give me a positive 9x. Then I'm going to fill it in with a 0, and I'm going to cover the second term like that. So 1 times x is x, a positive, and then negative 3x times x is negative 3x squared. And once you're here, you can add straight down, and again, you would get the same answer, which is 3x squared plus 10x minus 3. Like I said, I won't be using this one, but I know that when we start getting into longer terms, like trinomials, some teachers actually prefer this method, but you won't see it in my class any more than this right here. Okay, so here is our next one. We touched a little bit on this at the end of last semester. Now it looks like we just have one binomial, but this is actually raised to the power of 2. The most common mistake I'll see here is that people want to distribute that squared into each term. That's not correct. This is actually, if I were to expand this, this would be 2 of these here. So I have 2x minus 1 times 2x minus 1. And this turns into another by. So a binomial times a binomial. And we can use the area model again to solve these. Or you can use a different method if you prefer. I'm just going to solve these using area models because that's what I would prefer. Okay, so I get 4x squared minus 2x plus 1. Use my peanut. And my final answer is 4x squared minus 4x plus 1. So those two are really just a review of what we've been doing already. So let's jump into something new. Let's look at this and let's identify what we're looking at. So in this one, we said that this was a by because they're both binomials. But in this one, we have a by, we have 1, 2. So this is a binomial, but we're multiplying that by a 1, 2, 3 by a trinomial. So this is actually a bi-tri. So using the area model, we want to know what this equals. Now, so far with the area model, we've only done by's, meaning it's a 2 by 2. But since this is a 2 times a 3, we're going to make our area model fit that. So here is my 2, 1 and 2, and I'm going to make this long enough for 3. So that's going to be 1, 2, and 3 by 2. So now I've made this big enough to satisfy the dimensions of what I'm actually multiplying. So since I have 1, 2, 3 up here, I'm going to put my x squared minus 4x plus 1, and then my x plus 2. From here, it just turns into the same thing. We're going to take it one step at a time. So x times x squared is x cubed. 2 times x squared is plus 2x squared. X minus 4x is minus 4x squared. 2 and negative 4 is negative 8x plus x plus 2. So when we did these before, we had a peanut that combined our like terms. We still have those here. We have these diagonals, an x squared and an x squared. So we could combine those two. But then we also have x's that are like terms here, which we could also combine. But these two are not like terms with each other. So we have to keep that in mind. So here I have x cubed. 2 minus 4 is minus 2x squared. Negative 8 plus 1 is minus 7x, and then plus 2. And that becomes our final answer. Now, if you wanted to use one of the other methods, like distribution, for example, you would be able to do that. So I'm just going to do distribution really quickly. I'm going to set it up. I'm not going to solve it. If you wanted to use that, you could break up either one you want. I'm going to break up the binomial just because it's 2 of them. So I'm going to do x and then plus 2. And then you would multiply it by the trinomial. And then again, you would just multiply. So distribute, 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 and then combine the like terms. But ultimately, it would be the same steps, just a little bit longer. All right, so we've seen these. These we're really familiar with. This is a by times a by. But what happens if I add another one? Say we add x plus 4. This is now a by. So I am multiplying 3 things together. Now, when I think about my area model, I can't turn this into a 3-dimensional thing. So what I'm actually going to do for these is I'm going to focus with 2 first. I'm going to multiply these 2 first. And for now, I'm going to completely forget about that x to the 4th. So I'm going to take this and I'm going to do my area model. And I'm going to do x minus 3 and x plus 2. So my peanut would give me x squared minus x minus 6. but that is just this yellow part here. I still have this other part that I need to multiply. So what I'm going to say is that this is actually, instead of the yellow, I'm going to replace it with this, x squared minus x minus 6. Now I have a trinomial that I'm going to multiply by this binomial here, x plus 4. Well, now this problem just turns right back into the problem that we did last. So we're going to follow the same steps. Now you can do a 2 by 3, or you can flip it the other way around. Like this. So I would get x squared minus x minus 6, and then x plus 4. It doesn't matter how you set it up. What matters is what's inside. So I'm going to do x cubed, negative x squared, negative 6x, positive 4x squared, negative 4x, and then negative 24. Now if I did my peanuts, I would have one here and then another like terms here. So my final answer would be x cubed and then plus 3x squared and then minus 10x minus 24. As my final answer. Okay, and then this is going to be our last one for today. What I'm doing here is I'm combining almost everything that we've done so far to make sure that we understand it. So the first thing I want to notice here is that I have a squared. So if we think back to when we did earlier, when we had an 2x minus 1 squared, remember that that actually meant that I had two of those. So when I expanded that, I had 2x minus 1 and then 2x minus 1. So for this one here, I'm going to do the same thing. I'm going to write it underneath it just because I feel like it's super crammed here. So it's going to be x minus 3, x minus 3. And then I'm going to have that x plus 2. Now this worked out nicely with my colors because now I'm going to focus in just this part first, in this like reddish purple color. I'm going to do my area model. It probably didn't need to be this big, but that's okay. Okay, I get x squared minus 3x minus 3x and then plus 9. Combine my like terms here, and I get x squared minus 6x plus 9. For this part, so I'm just going to draw an arrow, but then I still need to bring this part over as x plus 2. So I'm going to set that equal right there. Right, now that I have a binomial times a trinomial, I'm going to do my area model. And like I said, it doesn't matter which way you do it. So for sake of space, I'm going to do mine this way because it doesn't matter. As long as you set up your dimensions based on where you want each thing to be placed. So since my 3's are up here, I'm going to do x squared minus 6x plus 9 that way, and then my x plus 2 this way. And then I solve. So this gives me x cubed plus 2x squared minus 6x squared, and then minus 12x plus 9x, and then plus 18. So let me identify my like terms, which is this right here and this right here. And I get x cubed, and then minus 4x squared minus 3x plus 18 as my final answer. And that's it. So if you guys do want extra practice on this, this is section chapter 4.2 in your textbook, and that should give you enough practice for you to do everything. Bye.